My name is Sorensen. I'm a data scientist with a background in mechanical engineering and software development. For my galvanized capstone project, I work with a small startup company called Predictive Fleet Technologies based in Michigan. What they do is they help fleet owners manage their fleets by providing information and details about the trips that the drivers make. The overall objective of this project is to classify driver behavior into groups and to identify relative cost per mile for each group. So a quick outline of the project. All the data comes from the engine control module, which is a sensor that is installed in all vehicles. This sensor records a lot of information about the trips being made, and we want to identify features that depend only on the driver. Factors like top gear usage, use of cruise control, or hard brakes are all examples of driver behavior. The truck load, however, is not a function of the driver behavior, so we will want to take that out of the equation by normalizing the load. And also we want to cluster trips to see if any given driver has most of his trips in one cluster, and finally we want to rank drivers based on a combination of drive fuel economy and risky or unsafe driving. Obviously it's not enough to just have a very good fuel efficiency if you are being a hazard to yourself or others on the road. As mentioned, the truck load is not a function of the driver behavior, so we want to take that out of the equation. By setting up a regression model which relates the drive fuel economy to the other features, we can then use this model to calculate an adjusted drive fuel economy by replacing the actual load with a standard average load of 45%. To the left, we see a scatter plot of the drive fuel economy versus the average vehicle speed, and to the right, we see what happens when this driver independent feature has been removed. And as expected, there is a strong correlation between the drive fuel economy and the average vehicle speed. In this case, there's a correlation coefficient of 0.85. Clustering of trips is done by use of k-means clustering. In our case here, we ended up with an optimal number of clusters to be 5, but with 3 of those clusters containing most of the trips and 2 small clusters containing the remaining trips. The initial assumption that any given driver would have most trips in one cluster turned out to be quite accurate in this case. With the engine control module recording as much information as it does, a big part of this project turned out to be narrowing down the number of features that go into the model. And we have already identified the load factor as important for the fuel economy, and also the average vehicle speed. I set up a random forest regressor to estimate the importance of other features, and turned out that several driver-dependent features play a big part in the drive fuel economy. Features like the use of top gear and the use of engine brake and engine fan are all important in this model. In our case here, the fleet owner would like to be able to rank his drivers based on a combination of drive fuel economy and safety. Currently, we do not have enough statistical data about actual crashes and other accidents. So, as a first step, the assumption is made that the number of hard brakes a driver makes is a direct indicator for unsafe driving. In this case here, we have a driver with the best fuel economy and the lowest number of hard brakes. So he would obviously be ranked as the best driver. But there's a driver up here who may have an unacceptable number of hard brakes, and would consequently be labeled as the worst of the drivers. So by ranking, or after ranking the drivers from best to worst, a decision tree was trained in order to be able to quickly assign a score to any new trips just by entering the number of hard brakes and the adjusted fuel economy for that particular trip. And this score could then be used to determine if action is needed, like rewarding good driving or provide education, training to a bad score. More data, as mentioned, is needed, and this is where the next big step in the development of this model would be to include more factors that could improve the way the safety factor is included in the model. But as mentioned, we need more data for that. So, if you would like to hear more about this project, you're welcome to email me, find me on LinkedIn or GitHub, and I want to thank you for your attention.